Good morning, this is Ms. Billerbeck, and we're going to talk about 4.3 problem solving involving quadratics. So our first problem is the sum of the squares of two consecutive positive odd numbers is 394. Find the numbers. Okay, so I've underlined the important things of the paragraph of the question. So sum of the squares of two consecutive, meaning next to, positive odd numbers, that's 394. So first we define the variables. So x is going to be the first odd number. And then odd numbers are 2 apart. So we're going to say x plus 2 is the second odd number. All right, so now let's put it together. So we have the sum of the squares. So we have x squared plus x plus 2 squared equals 394. So the sum of the squares of two consecutive positive numbers is 394. So we just made a little equation stating what they said with words. So let's this is a perfect square trinomial. So when recognizing that, you should be able to see that that's x squared plus 2 times 2x, okay, 2 times 2x plus 4, or 2 squared. Let's do that. Okay, equals 394. Okay, so that's the perfect square trinomial expansion. Okay, if you don't see that, you can do FOIL, or you can do a little box like this and do x plus 2x plus 2 and have x squared, 2x, 2x, and 4. Okay, so that's why we have two 2x's. There's 1, 2, and then that becomes 4. So let's just make that 4 right now. And let's save some space and make this a 4x. All right, so let's subtract the 394 from both sides. And at the same time, we're going to combine this 1x squared with a 1x squared, which is 2x squared plus 4x. And now we have minus 390 equals 0. All right, so diamond box does not work very well when we have a common factor. And these are all even numbers, so they have the common factor of 2. So we have to pull the 2 out. So we have x squared plus 2x minus, and that becomes 195 equals 0. All right, so now we factor this. So we have the diamond. So there's a 1 here, so 1 times negative 195 is just negative 195, and we have 2x here. So these numbers are very close together because they're only a 2 apart. One is positive, one's negative. So if we look at that really quickly, we have multiplies to be negative 195, adds to be 2. And we want to be close together. So we know the bigger number is going to be positive because we have a positive number. So if we go and start at the beginning, negative 195, we see we have 194. That is so far off that we might as well start trying something closer. Now it ends in a 5, so let's try negative 5. So when we divide 195 by negative 5, we see we have 339. Okay, so when we add that together, we have 34. We're getting closer. Okay, so let's try. So 39 is 3 times 13. So that helps us a bit. 3 times 5 is 15. So let's pull a negative 13 out and take 15, which makes 195. And now we have 2, and we found it. So this is negative 13 and 15. So sometimes when we do this, it helps us figure out the factors that we can't see right away. All right, so now we see negative 13, 15. So we see that this equation here is going to be 2 times x minus 13, x plus 15. Now you might say, wait a second, why didn't you do the box? Okay, when x is 1, we can go directly to the diagonal. So let me show you that. So with the box, okay, we have x squared here, negative 195 here, we have negative 13x, and we have 15x. Okay, the greatest factor here is 15. We have x plus, and then x. And then this greatest factor is negative 13, because 13 times 15 is 195, and 15 times 13 is 195. So that's where we got our x minus 13, x plus 15, directly off these diagonals. So this only works when x equals 1. When x is not 1, we need to use this box. Now we're going to use the property that one of these has to equal 0 if it equals 0. So we use the additive inverse, and we see that x equals 13. If we did that with this other one, we would see that, put this up, we have x plus 15 equals 0, we'd have a negative number. So x would equal negative 15, but the question said it was positive, so it has to be the positive 13. So this negative 15 is an extraneous answer, okay? So that means that the answer for this, our lower number, x, we just defined it as the first odd number. So our first number is going to be 13. And the second odd number is 13 plus 2, which is 15. Okay, so now let's double check. So if we put in 13 squared, which is 169, and 15 squared in there, that's 225. If this is correct, it should add to 394. So we have 14, 9, 394. So it checks. All right, let's look at a different problem. So the perimeter of a rectangle is 44. So the area of the rectangle is 117 centimeters squared. So find the length of the shorter side of the rectangle. So let's take a look. Remember, we want to draw pictures as much as we can when given geometric problems like this. So we have a length, we have a width, we have a length, we have a width. Okay, so we see we have 2L plus 2W is going to equal 44. So perimeter is twice L plus W, and we're given 44 equals 2 times L plus W. So if we divide by 2, we get 22 equals L plus W. All right, so now if we subtract W, this side, okay, we get L equals 22 minus W. So now we have L in terms of W. Okay, so now we have the area. So area is length times width. Well, we have L in terms of W, so we can say 22 minus W times W equals 117. Okay, if we distribute this, we end up with 22W minus W squared equals 117. Okay, so now what we want to do is move things to the other side. So W times W, okay. All right, so we're going to take let's add this W squared and add W squared over here. And we can actually do this all at once. So fasten your seatbelts. So now we have 0 equals, and I'm going to rearrange this W squared minus 22W plus 117. All right. So let's take a look at what we've got. So we want to do a diamond on this, and we have 1 times 117 is 117, and then we have negative 22. So we ask what multiplies to be negative 22 and adds to be what multiplies to be 117 and adds to be negative 22. Okay, if we don't know that, we can play around with some of the numbers. So 117 is divisible by 3. So let's do 3 times, let's see, that gives us 39. Okay, one of them has to be negative, so the 39 has to be negative. So that gives us negative 36, so that's a little big. Okay, but we do have 3 times 13 in there. So we can put in 9 times negative 13. It looks like both of them have to be negative because we have a positive here and a negative here. So let me fix that really quickly. All right, so that gives me negative 42, and this one gives me negative 22, which is what we're looking for. Okay, so now we have it, and again, W has a coefficient of 1, so we can go straight from this negative 9, negative 13, and we see that when we put it back together in length, this form, we have, let's see, W minus 9 times W minus 13 equals 0. So that means W minus 9 equals 0. We add 9 to both sides, and that gives us W equals 9. We have W minus 13 equals 0. We add 13 to both sides, and that gives us W equals 13. Now we have to go back, read what they're asking us for. It says find the length of the shorter side of the rectangle. Well, 9 is the shorter side, so we're going to write 9 centimeters for our answer. Okay, and we can quickly check to see if we did it right. So we have 26 plus 18 gives us 44. Okay. And then if we multiply this 9 times that, we get 117, so we're good to go. All right. So let's see what else we have in store for us. Example 3. Okay, so we have a rectangular swimming pool, measures 25 meters by 6 meters. A meter is about 3 feet. Okay, so it's a pretty long pool. It's about 75 feet. It is surrounded by a path of uniform width. If the area of the path is 102 meters squared, find the width of the path. Okay, so we're only finding the width of the path. Okay, so we have to draw a picture because a picture is worth 1,000 words. And in this case, it will save you a lot of pain. Okay, so the first instinct is just to add. If x is the width of the path, we define our variable that way. It's very easy to just say, oh, well, it's just going to be 25 plus x times 6 plus x. But no, it is not. So that's why we have to draw a picture. So this is 6m. This is 25m. This is x right here, this distance here. This is x. This is also x. This is also x. Okay, this little distance here, this little distance here. So this little distance here is x, and this little distance here is x. So you see why that could cause a problem. Okay, so when we write the area formula, so area is length times width, and we know that the area of the pool is 6 times 25. Okay, so our area of the pool ends up being 6 times 25 is 150 meters squared. And now we want to add the area of the path, and that is 102 meters squared. We add it together and we get 252 meters squared total. Okay, but when we actually do this, we see, oh, well, it's 2x plus 25 times 2x plus 6 equals 252. Ooh, that would have caused a lot of problems if we hadn't set that one up right. Okay, so let's do a little box here just to make it easy for us to multiply. You could also do FOIL, but some people like this box a lot, so we're gonna do the reverse of the diamond box. So this is 4x squared, this is 50x, and this is 12x, and that's 150. All right, so we can combine these two because they're like terms. So that gives us 4x squared plus, and that's 62x plus 150 equals 252. All right, so let's move this over to the other side using an additive inverse. And that gives us 4x squared plus 62x minus 102, which is what we started with, the width of the path, equals 0. Now we can't do the diamond box with a common factor all the way across. So there is a 2 in every one of these. So we have 2 times 2x squared plus 31x minus 51 equals 0. All right, so let's set this diamond up. We have 2 times negative 51 is negative 102. And then this gives us 31. All right, so after a few iterations of what would work, 2 wouldn't work. So 2, we did a quick one here and had negative 102 and 31, and we decided, okay, let's see what's 31 apart, and we took 2 out. So we had negative 2 and positive 51. Well, that gives us 49. But this is also divisible by 3. So if we took 3 out, we'd get 30. That'd be 34. And when you add that together, that's 31. So this is going to be negative 3, 34. All right, A was not 1, so we have to use the box. So we have 2x squared is our first term, and we have negative 51 here, negative 3x, and 34x. Okay, 34 and 51 have 17 in common. 2x squared and 3x have x in common. 2x squared and 34x have 2x in common, and negative 3 and negative 51 have negative 3 in common. So when we look at this, we see x plus 17. Well, let me write it here. Okay, so this factors as 2 times x plus 17 and 2x minus 3. Okay, so, sorry, it's so little. So x plus 17 equals 0. So that means x has to be negative 17, but that doesn't make sense because you can't have a negative width. But if we add 2x minus 3 equals 0, and we added that 3 to the other side, let me grab another board really quickly. Okay, if we add that to the other side, we get 2x equals 3. We use a multiplicative inverse, and we get x equals 3/2, or 1.5, and that's 1.5 meters. So if we remember what meters seems to be in terms of feet, so a meter is about 3 feet. So 1.5 would be about 4.5 feet if you're just approximating it. Okay, so that would make sense. Okay, so it would seem that the width of the pool, of the path, is 1.5 meters. Okay, so if we check that, 1.5 times 2 is 3. So 3 plus, so if we go back to our original drawing here, so 6 plus 3 is 9, 25 plus 3 is 28. So if this is true, then 28 times 9 should be the total area. So that's 72, and then 18 plus 7 is 252, and before we had 252 for our total area when we added the two areas together. So this is correct. So there you have it. We worked the long path of it to find the width of the path, and we checked it, and we are right. So you have a wonderful day. Bye-bye.